Hello, my name is Ross Smith, and today we're going to review a mobile application created with ADF-Mobile by Oracle. This is called the Substation Inspections application. It was created for PowerSouth by PITSS America. I served as the team lead and was the application's software architect and user interface designer. This application was designed for use at a power company that maintains equipment at remote substations. These stations are located deep in the country, away from the office, and often away from cell phone reception. Field inspectors take iPads with them to the substations and perform maintenance checks of all the equipment there. Then they answer a questionnaire about the work they did in the process. This application lets inspectors capture these reports along with equipment photographs and GPS coordinates of the substation. All the data is stored locally and may be synchronized with the application server when the inspector returns to a place with an internet connection. The application is distributed only through Enterprise MDM and is closely monitored by IT. After launching the application, we begin at the Sync screen. This is where the user may synchronize this iPad's offline data with the application server. They begin by pressing Connect to test for valid connection over the virtual private network. This tests for valid connection over the virtual private network. Using a VPN guarantees that network traffic between the iPad and PowerSouth's internal servers are secure. Without a valid connection, the app will not make any attempt to send or receive sensitive data. Once the connection is verified, the user may start the synchronization. For this app, we determined that two sync modes were appropriate: Total Sync and Fast Sync. Total Sync empties out all local data and downloads every application table and file from the server. This process takes a few minutes. It is necessary when the app runs for the first time or when there are updates to the configuration tables, which do not change very often. Fast Sync only downloads the server data that changes on a regular basis. This includes recently completed inspections and meter readings of equipment. The result is all iPads in the field carrying identical records after a quick update. Both sync modes will also upload completed inspections that were collected on this device. Inspections that are completed and incomplete are listed here for the user's easy reference. Selecting either one will take them directly to that inspections editor. For now, let's assume we are an inspector in the field who's completing an inspection that was started earlier by someone else. Let's start by going to the inspections browser. This is where we choose the substation we want to inspect. On the left side, we have a list of all of the substations, and on the right side is a list of inspections for that substation. Here, we see Alabama River Newsprint has one complete inspection ready to be uploaded to the server. Alaqua has two inspections. This one, marked Last Completed, is an archival report that cannot be edited. It is there for the inspector's reference. Every location hangs on to its most recently completed inspection just like this. The other inspection is the one that we have to finish. If we select it now, we will see a message prompting us to log in. This means the last user logged out before giving us the iPad, and we will need to log in to resume doing work. Until we do this, the inspection behaves like an archival report, and it cannot be changed. Because inspectors will often need to log in when they have no internet connection, we created a login process that functions offline. Users log in with their employee short name and an ID number. This is considered safe to keep in the locally encrypted database. Now that I'm logged in, I can get to work. This screen is where most of the application's work is done. The left column shows all the different equipment to be inspected at this substation. It is grouped by type. Different types of equipment have different questions. For example, the station's control house has questions for its door lock, temperature, and exterior walls, whereas oil breakers have questions about electrical ground, bushings, cabinets, air pressure, and so on. It is worth noting that these questions are configured entirely from tables. All of the equipment, all of the locations, all of the question types, and their answers are data-driven. Configuration tables on the server are responsible for determining the structure of the entire inspection process. None of those are hard-coded in the form or in the interface in this application. When this report was created, the inspector chose which pieces of equipment he wanted to include. That is done here with the Choose button. The Choose list shows all equipment at this location that is not currently included in the inspection. By checking these options and confirming, I'm adding them to the inspection. Alternately, I may choose the All button to add every piece of equipment to the inspection, which is how most often the inspectors work. If I want to remove a piece of equipment from this report, I simply swipe to show the Delete button and then press it. Each piece of equipment and each question is marked with an icon. A green icon means no problems were found and all necessary questions have been answered. A red icon with an exclamation mark means the equipment has some questions that were not yet answered or not answered completely. A yellow striped icon means all questions are answered, but issues were uncovered during the inspection. For example, this single-phase regulator has fuses that will need to be replaced soon. These icons allow inspectors to rapidly assess where work needs to be done for equipment and to complete the report, respectively. Because the application must work outdoors in direct sunlight, we designed the icons to be very distinct, both by color and by contrast patterns of light and dark. Let's return to our example. I am an inspector completing this report. The last inspector did not have the right fuses in his truck to finish the work, but I do. So I go and replace the fuses for this regulator. I can now update the report accordingly before it is submitted. To indicate this, I select the appropriate checkbox reading Fuse Blown or Missing, and check the box to indicate that work has been completed. The application will retain my username and associate it with this portion of the inspection. When this inspection is completed and synchronized with the server, the manager reviewing the inspection will see that I completed this part of the report. Thus, we get very detailed information about who was responsible for finishing which parts of a long or complex inspection. Now let's consider a different scenario. I am now an expert inspector, and I know that the last inspector heard a strange noise from this machine and thought it was an old fuse that had to be replaced. I know that this machine is making a weird but harmless sound and that the fuse is actually fine. I perform the function test and confirm that everything is okay. To indicate this, I check the top-level checkbox. This hides the other prompts, which are only selectable when an issue is found. Now when I press Done, the question updates its icon to green. Just as before, my login is associated with answering this question. If an issue were found with the function test, it would be my responsibility, not the inspector who started the report. Each of these questions follows a similar pattern. Selecting the question shows a window with a hierarchy of prompts. Checking off the top-level checkbox indicates that there is no problem. Unchecking the box indicates there is an issue, and the inspector must select a child issue to explain it. For example, in the ground condition question, the inspector may find that the electrical ground is completely missing. This is a dangerous situation. If the inspector did not already know the safety rules, the application would give them an inline alert to stop immediately. Let's take a look at the oil breaker. Here we have an input type question, where the user must input a reading from a meter on the machine. If I enter 100,000 here, the answer changes its status from incomplete to complete with no issues. The application also updated the number of operations question. This is a special case where the operations can be calculated as the difference between the current reading and the last reading for this piece of equipment. Selecting the number of operations question gives us the ability to override the default computation. Back to the single-phase regulators. We can see another input type for answering questions. There are 3 questions for collecting readings from a drag hand on the faceplate of the regulator. These readings are always from a set list of values, so we created them as a single selection drop-down list. This saves the inspector some time when entering repetitive values. As you can see, the hierarchy of equipment, questions, prompts, and input types keeps users focused on the task at hand. With the icons, they always have complete information at a glance, from which they can rapidly drill down to machine problems revealed by the report. Requiring the inspectors to complete all questions and associating their username with their answers drives accountability and increases report integrity long before the data enters the system for validation. Let's go over the last few features. By touching the GPS button, I can use the iPad's built-in GPS chip and collect the user's absolute position. The iPads used in this deployment are cellular capable, and even without an active cell plan, they can get accurate coordinates. For any piece of equipment I inspect, I can also capture one or more photographs. Here we can see there are no existing photographs for this equipment. By selecting Camera, we use the iPad's built-in camera to take a picture, scale it to size, and save it here. However, we are running on the iPad software simulator, which has no camera. The image you see here is for process only, which helps us during development as we tested out the image data management features of this app. Finally, I'm ready to mark this report complete. By pressing this button, I'm acknowledging that the report is complete as is. However, the application will show me all missing or incomplete content just to be sure. The two pieces of equipment that I left out of this inspection are here, and if I failed to answer all the questions for equipment I did select, they are shown here. At this point, I can alter my decision by marking the report not complete, making changes, and then remarking it complete. At the end of the day, the inspector will take the iPad back to the office and log out. A manager there can handle the rest, starting a fast sync to upload all the completed work and download the newest inspections from other iPads. I hope this presentation has been informative. If you have any questions or any needs regarding ADF-Mobile application development, we would be happy to get in touch with you. You can reach us with this contact information below. Thanks for watching.